last section of chapter 1. I combined 1.6 and 1.7 together because they're both pretty short, simple, sweet, and easy way to end chapter 1. So they're going to be together. So I'm going to cover both lessons really quick. 1.6 is graphical transformations. So we're going to be looking at horizontal and vertical transformations, reflections, and then I know I said it. Desmos, use it, okay? You can use it to check your answers. You can use it to find your answers on your homework questions. So let's look at vertical and horizontal transformations. Remember, horizontal shifts left and right, vertical shifts up and down. These are the same transformations that you've learned back in Algebra 2. So hopefully it's just a little refresher. And so again, horizontal is left and right over the x-axis, and then y is up and down across the y-axis. And so if we have a, let's see, be a positive real number. And so if we have the function y equals f of x, if we have any c number that is inside of a parentheses, absolute value, square root, if it's an exponent, if it is in parentheses or a grouping symbol, then it transforms horizontally. So it translates horizontally left and right. Okay, I'm not gonna write left and right because I want to look at this right here. So, and it's always opposite of what you would think, okay? It's always opposite. So like drop your sign, switch your, drop your number, switch your sign. And so if we have this x minus c, okay, you would think that it would go to the left, towards the negative numbers. However, it's opposite because it's horizontal, it's in your grouping symbol, so a negative c moves to the right by c units, okay? In the same way, but opposite, if it's a plus c, you would think it would go to the positive numbers, but actually it goes to the left negative number to the left, okay? So if it's a negative, it goes to the right, positive, it goes to the left. Okay, and then vertical translation is up or down. And so we look at, this one is great. It's at the end, and it is what it is. There's no confusing, it is what it is. So K is at the end, and if it is just the plus C, that means it moves up towards the positive y values, and negative c moves down towards the negative, okay? And so let's look at some examples, and we're gonna look at some graphs, some equations, and establish what it does, okay? And so we're gonna describe how the graph of y equals the absolute value of x can be transformed given the equation. So if we have y equals the absolute value of x minus 4. So this minus 4 is at the end. It's not in a grouping symbol. So that represents a vertical transformation. And so it's going to be vertical shift 4 units down because of that negative 4. And that's it. So then if we have B, y equals the absolute value of x plus 2, this plus 2 is inside the absolute value. That's our grouping. It's opposite of what you would think. Plus 2 is actually to the left. Okay, so and this is a horizontal shift. So horizontal shift two units to the left, to the left, to the left, to the left. Okay, a little Beyonce there. Okay, so now if we look at these graphs, I'm gonna keep those. Okay, and so we said that this one was a vertical shift 4 units down, and so our parent function that we talked about in 1.3, you know, your 12 functions, absolute values for the origin, it looks like this. If we did 4 units down, it's 1, 2, 3, 4. This is our new y equals the absolute value of x minus 4. And then same with this one, our absolute value OG is right here through the origin, and our new absolute value of x plus 2 is 2 units to the left. Okay. And then let's talk about reflections. Okay, so you can have a reflection across the x-axis reflection across the y-axis or reflections of each other across that line. And so if we have, this is like our original, our xy. If it's a reflection over the y-axis, we have a negative x value. So negative x value. Okay, really, you're not going to see that much. Usually that's with like linear, and like you have your linear slope. That's when it's reflected across the y-axis. If it is reflected across the x-axis, okay, this is where your y value is negative. And so if you look here, our y value is negative, a negative y value. Okay, and this is like if you have a function and then right after the equal sign, there's a negative, that means it's going to be a reflection over the x-axis. Okay, and so let's look at, again, here's some reflections. So if we wanted to do a reflection across the x-axis, this means our y value is negative. Okay, and so right off the bat, we have y equals the negative y value. Okay, if it's reflected across the y-axis, your x value is negative. Okay, and so we would plug in a negative x for your equation. Once you solve, then it would be a reflection across the y-axis. And then through the origin, you have a negative x and a negative y. Okay, so if we have this is in Desmos, this is a screenshot. And so if we have the square root of x, the parent function we have is in blue. So that is one of our 12 functions that we have a transformation of. And so we have the square root of x, it starts at the origin, and it goes like this. That's our original. And so the red one is a transformation. And so to describe those transformations, there's a few things happening. And so if we look, we have this right off the bat in red, we have this negative, okay? And if you look, it is flipped upside down. And so that negative makes it a reflection over the x-axis. Since this is your x-axis, it's upside down that way. So reflection over x-axis. So that's your first. Okay, then we have this -3 that is under the square root, so that's like your horizontal transformation since it's in that group. If it's a -3, that means it moves opposite, and so you would think it would move left, and it actually moves right. So it's a horizontal 3 units, and then this +2 at the end is your vertical, and that's up 2 units. It is as it is, no tricks. So vertical up 2 units. I didn't say here, that was right, 3 units. Okay, and so from here to here, your origin, it moves to the right 3 units. So that would be right here, 1, 2, 3, and then it moves up 2, 1, 2, so that's right there. If you look, that's your new vertex, and it's flipped, okay? It's upside down. Instead of going up, it goes down. And so that is that. And so use Desmos. This is directly from Desmos. Use it to just check your answer. Use it to find your answers, okay? It's a resource there for you. Okay, lastly, modeling functions. So this is 1.7. You guys have been doing this, since like pre-algebra. It's basically determining you're going from vertical to algebraic, algebraic to vertical, and just figuring out, it's like lots of word problems. There's no really way to teach it other than just going over some examples to just kind of refresh it. But you guys have been seeing these problems since, 7th grade. So let's just do some examples. And so if we have a number increased by 5 and then triple. So a number increased by 5, so that means plus. So a number x, and then plus 5, and then triple. Tripled means times 3. So times 3, and it's that number increased by 5, that is first, okay? And it's whatever that results in, then you triple. And so it would be 3 times x plus 5, okay? And so that needs to be grouped, that x plus 5. 3, 17% of a number, x. So 17% of a number, I will say x. So 17% we need to change into a decimal. We can't do anything with 17%. So our decimals at the end of 17. We move away from our percentage sign to go away. So that would be 0.17 of means multiplication. So just times x, so 0.17x. And then lastly, 4 more than 5% of a number x. So it's 5% of a number x and then plus your 4, or 4 added to whatever this is. So 4 more than is a plus, and then 5% of a number, move it away. So that would be 0.5 of a number x of means multiplication x. Okay, so it can be represented as 4 plus 0.5x or 0.5x plus 4. Okay, addition is associative, so you can move it around, and it's the same thing. Okay, so there's that one, and that one. Okay, 21. One positive number is 4 times another positive number. Okay, the sum of the two numbers is 620. Find the two numbers. So we're looking for two numbers. So we are going to have two unknowns, which means we have two equations. So I'm going to say x and y are my two numbers. So one positive number is, so I'm going to do the first line first. One positive number is 4 times another positive number. So one positive number is x equals 4 times another positive number, we'll say y. So that's just x equals 4y. And the next one is the sum, which means plus, of the two numbers x and y is equals 620. And so x plus y equals 620. So now we have our two equations, two unknowns, and we're going to substitute one into the other to solve. And so if x equals this 4y, I'm going to take this 4y and put it in place of x. So now we have 4y plus y is equal to 620. So now we have one equation with the one unknown, the y variable. So 4y plus y is 5y is equal to 620. Okay, divide by 5. Y is equal to 124. Okay, and then now we just need to solve for x. So you can plug them into either one of those. I'm going to do the top one. So if x equals 4 times 124. Okay, so 124 times 4, 16, 8, 9, 496. So x equals 496. So there's x and there's y. Okay, another way you can check it is if you add them up together, you should get 620. Okay. Now let's talk about, so this one, I'm going to do, we have miles per hour, and so we're going to do some proportions with our correct units. So like unit conversions kind of a thing. So if we have a traveler average 52 miles per hour, so 52 miles for 1 hour, on a 182-mile road trip, how many hours were spent on the trip? Okay, so if we're traveling 52 miles per 1 hour, so we're going to set up a proportion that would be equal to 182 miles, and we're looking for x hours. I need to label this as hours here. So 52 miles for 1 hour would be equal to 182 miles for x hours. And then we can cross multiply. And we get 52x is equal to 182. Divide by 52. Okay, we get x is equal to, I think it's 3.5. Real quick, we'll do 182 divided by 52. Yep. So x equals 3.5. And so what that means, since we're looking for x hours, it would take 3.5 hours to travel 182 miles. So 3.5 hours. So anytime that you're doing these like real world applications or just word problems, before you just type in your answer and call it a day, double check to see if like that makes sense, okay? I think this was the last one. So Mark received a 3.5% salary increase. His salary after the raise was $36,432. what was his salary before the raise? Okay, and so a couple things. So first, we need to convert this 3.5% into a decimal. And so we want to get rid of our percentage, so we're going to move it away. So that would be 0.035. Okay, and so if we have a salary increase, that's going to be over 100%. So we're going to add a 1. So that plus the increase is a 1, so that would be 1.035. And so whenever we're trying to find a percentage of something, we multiply. And so we're trying to find 3.5% raise of his starting salary. That equals his new salary. So we're going to take our percentage, we're going to multiply it by his old salary, which we don't know, we're looking for, that's X. If we do that, that would equal 36,432. That's going to equal what his new salary is. And so we just solve for X. So divide by 1.035, divide by 1.035, okay? And so it's 36,432 divided, 36,432 divided by 1.035, and we get X is equal to 35,200. Okay, so he was making 35,200. He got a 3.5% increase. We multiplied 35 times 1.035. We get 36,432. Okay, and so you can kind of work backwards and double check. And so if it's a salary increase, you add 1, and if it's a salary decrease or something decrease, we subtract our percentage from 1. Okay, and then you can multiply. And that's that. Okay, that's your lesson. It's pretty easy lesson for both of them. So let me know if you have any questions. There are 11 total questions from both together. So let me know. And we're done with chapter 1. Okay, bye.